Okay, here's an introduction to chemical bonds. We can define it as the force that holds two atoms or their ions together. Some atoms do not form chemical bonds, notably the noble gases. And the ones that do form bonds oftentimes do so in order to obtain those noble gas configurations. For example, when chlorine gains an electron, it becomes a chloride. When sodium loses an electron, it becomes a sodium cation. There's then an ionic bond that can form between them. So we have several different bond types. If the bond is strictly between metals, not surprisingly, that is a metallic bond. An example would be an iron-to-iron bond. If the bonding is between a metal and a non-metal, one left of the staircase and one to the right, well then you have an ionic bond that we just described. For example, sodium chloride. Now, if the bond is involved in atoms that are only to the right of the staircase, these can form lots of different bonds, and they can have lots of variety to their structures. We call those covalent bonds. For example, a carbon to chlorine bond would be a covalent bond. Within the realm of covalent bonds, those electrons are being shared, but they might not be doing so evenly. For example, if you have a carbon-to-carbon bond, they're the same nonmetals, and I think it's fair to say they'd have an equal desire for the electrons, so we call that a nonpolar covalent bond. By the way, the only other type of bond that we did not mention was similar to metals, where you have sort of an infinite lattice of bonds, but they're not in the metal side, they're on the covalent side. We call those covalent network solids, and that includes things like diamond, graphite, glass. Okay, continuing with the polarity of these covalent bonds. If they're different nonmetals, well, the oxygen is more electronegative in this case than carbon, so you would have a polarized or a polar covalent bond where the electrons would be unevenly shared. In this case, they'd be more attracted to oxygen than to carbon. And an exception is a carbon-to-hydrogen bond, where, after all, hydrocarbons are very greasy nonpolar substances, and we define the carbon-to-hydrogen bond as a nonpolar covalent bond, even though they are different nonmetals. Okay, tell me if this is an ionic, covalent, or a metallic bond. Sodium chloride, metal to nonmetal, ionic. Fluorine, nonmetal to nonmetal, identical, nonpolar covalent. Iodine, similar, nonpolar covalent. Magnesium chloride, those are metal to nonmetal bonds. That would be an ionic bond in each case. Carbon dioxide, both nonmetals, unevenly shared. Covalent bond. The sodium to oxygen bond is also an ionic bond. Iron to iron would simply be a metallic bond. This is an introduction to chemical bonding.